Alright, we're going to be looking at how to use the graphing calculators with our normal distributions. So let's look at the following questions. So everybody make sure you have a calculator. Go ahead and clear your calculators. So sometimes when we draw that normal curve, we're not always going to hit those cutoffs for the standard deviation. So let me show you how to use a calculator when we don't hit those cutoffs. So let's look at the following example. A machine fills 12-ounce potato chip bags. It places chips in the bags. Not all bags weigh exactly 12 ounces. The weight of the chips placed is normally distributed with a mean of 12.4 ounces and with a standard deviation of 0.2 ounces. The company has asked you to determine the following probabilities to aid in consumer relations concerning the weight of the bags purchased. Alright, let's fill out our curve here. Like I said, I'm going to show you how to use the calculator. Alright, remember our mean goes in the middle, so 12.4, and our standard deviation is 0.2. So that's our scale. We're going to add 0.2, and we're going to subtract 0.2. Okay. If you purchase a bag filled by the dispenser, what is the likelihood it's less than 12 ounces? Okay, and like I said, I know that this hits one of our marks, but let's look at how to use the calculator. So this is likelihood, same thing as probability. We'll look in the probability that x is less than 12. We treat less than equal the same way. Alright, on the calculator, what we want to do is we want to put this in as an inequality. Now your calculator requires a lower bound, an upper bound, and then the mean and standard deviation. That's what these arguments are here. Alright, our lower bound. Technically this thing keeps on going forever, so we can just put a really small number, like negative 1,000. Our upper bound, because it stops at 12 and we're looking at less than, my upper bound is 12, my mean is 12.4, and my standard deviation is 0.2. So that's the arguments I'm going to put into the calculator. Alright, where do we find this? Here's the instructions here. Let me walk you through it on the calculator. Alright, so your calculator. Alright, let's practice what I preach. I'm going to clear my calculator first. Alright, hit home, and I just want to be in the regular calculate screen. Alright, we want to go to menu, either probability or statistics, either one. Let's do probability. And then we want 5 again. So probability 5, distribution 5. Now we're only going to be using the 2 and 3 on this. Normal CDF, because that's the area under our curve, and then inverse norm. And I'll show you how to use both of them. We want normal CDF first. Alright, lower bound. Alright, we can use this default as our lower bound. This is negative 9 and 999 zeros in scientific notation. Our upper bound, and we can hit tab to get to our next value, is 12. Alright, standard normal curve has a mean and standard deviation of 0 and 1, but we want to change it for our problem. So our mean was 12.4, and our standard deviation was 0.2. You're telling the calculator where to center their curve. Alright, so hit tab and hit OK, and that's your area under the curve. That's the likelihood. Okay, let's round to 3 decimal places. So 0.023. So our answer here is 0.023, or 2.3% of the chips are going to have 12 ounces or less in them. So you get a very similar answer, not exactly the same, but a very similar answer as if you were to use the curve. Alright, we're just going to practice using the calculator some more. Alright, look at the following. If you purchase a bag filled by the dispenser, what's the likelihood it's more than 12 ounces? Okay, so let's go back. Let me pick up that. See if I can take a. Okay, so this time I want more than 12 ounces. Well, from our previous one, we know that 12 is here. So I want more than 12 ounces. So I'm looking for this area under the curve. Alright, so lower bound is going to be 12. My upper bound, I want some big number, positive big number now, and then mean and standard deviation. And like I said, you don't have to memorize this because the calculator tells you what it needs. Alright, so let's go back in our calculator again and do the same thing. So we're going to go to menu, probability, 5. We're still looking for an area under the curve, so we're in normal CDF. Now this time I've got to change that lower bound to 12. And my upper bound, you just put a bunch of zeros, you can't go too big. and then mean, and standard deviation. All right, hit OK, and that's the area under our curve. Okay, so it's round to 3, so 0.977. So our answer here is 0.977, or 97.7% of the time we're going to have more than 12 ounces in the bag. All right, let's look at the next one. If you purchase a bag filled by this dispenser, what is the likelihood it is less than 12.6 ounces in it? Okay, so let's look at your curve again. I think it's helpful to draw your curve because that helps you when you set up what you're going to put in the calculator. All right, so we want less than 12.6. So 12.4, 12.6. So we're looking for less than. Okay. All right, so remember it's lower bound, upper bound, mean, standard deviation. So our lower bound here is a really small number. We can use the default on the calculator. Our upper bound, it's stopping at 12.6. Our mean is 12.4, and our standard deviation is 0.2. Okay, so let's look it up in the calculator. So we're going to go Menu, Probability, Distribution, and we want normal CDF. We only use those two. All right, so our lower bound, upper bound is our 12.6, our mean, and our standard deviation. All right, when you're ready, hit OK, and that's the area under the curve. So 84.1%, or 0.841. So it's 0.841. Remember, the SOL requires to put that 0 placeholder, or 84.1% of the time we'll have less than 12.6 ounces of chips in our bag. Okay, let's do one more like this, and then we'll do the other kind. If you purchase a bag filled by this dispenser, what is the likelihood it has between 12 and 12.6 ounces? All right, let me paste my picture here again. Okay. All right, so we got 12 and 12.6. So we're looking between these two values. All right, so notice we're bounded on both sides. So your lower bound is 12, your upper bound is 12.6, your mean, and your standard deviation. And we always use normal CDF. So if you're looking for the area under the curve, so looking for area, we want to use normal CDF. And we always use CDF, never PDF, so it's always the number 2 one. Okay? All right, so calculator. Menu, probability, distributions, normal CDF, number 2. All right, our lower bound this time was 12. Upper bound was 12.6. Mean, 12.4. Standard deviation, 0.2. All right, tab OK. And there's your answer. Round to 3, 0.819. So 0.819 or 81.9%. Either answer is acceptable, writing it as a percentage or writing it as a decimal. All right, so there's some examples using normal CDF. Let me show you the other kind. Just like we did 2 different kinds in your notes by hand, we're going to do it here too. Okay, so here we said describe the contents of the bottom 5% of the bags. All right, bottom 5%. So I want to know what cuts off. My mean is still 12.4. I want to know what this value is. What cuts off the bottom 5% of bags? 5%. We have to change it to a decimal to use it in the calculator. So we need to change to decimal. Okay, this is when we're going backwards. They give us the area under the curve. We've got to go backwards and find a value across the bottom. This is when we use what we call inverse norm, because we're going backwards. Now, inverse norm requires the area to the left. That's going to be our percentage. and then your mean and your standard deviation. Alright, so our area to the left here, because this is the bottom 5%, is 0.05, and then our mean is 12.4, and our standard deviation is 0.2. Alright, if you notice that was number 3, this is number 3 on that list. So calculator again, you're going to go menu, probability, distributions, and we want inverse normal, inverse norm. Alright, this is area. You've got to remember this is always area to the left. So we want to put in 0.05 because it's the bottom 5%, 12.4 for mean, and 0.2 for standard deviation. So this is a cutoff across the bottom. Alright, so let's round 3 decimal places. So 12.071 ounces. So the bottom 5%, the cutoff for the bottom 5% is this value. 5% of the bags are going to have 12.071 ounces or less. Alright, so that's if they tell you a bottom. There's some underline it. Remember, we need area to the left. So look at the next question, however. So here again, we got our curve, 12.4. This says the top 2.5%. Alright, change it to a decimal, 0.25. Alright, this is that, so I'm looking for this cutoff here. Now, this is the top. I've got to have the area to the left. Now, remember, the area under the curve is equal to 1, so I want this region here. Alright, so I need to go to find the, because that's what I got to put in the calculator. Why? That's what the calculator wants. Got to give the calculator what it wants. So 1 minus 0.025 is 0.0975. This is the value that we have to put in the calculator, this value, because it's the area to the left. So our command is going to be inverse norm, area to the left, which is that 0.975, mean, standard deviation. All right, let's do that. So inverse norm, so menu, probability, distributions, inverse norm because I'm going backwards. I need the area to the left, so I have to do a little bit of work to get that. Mean, standard deviation. All right, tab OK. So that's my cutoff, 12.792. This is 12.792 ounces. So the top 25 or top 2.5% will have 12.792 ounces or higher. Okay? Alright, so just be careful on these. You've got to look at the top or bottom, because if they tell you the top percent, you're going to have to subtract from 1. So make sure you look for top or bottom percent. And also look at your answers. Make sure they make sense. If I'm in the top 2.5%, I should be more than 12.4 ounces. Alright, now all of these problems you could have used the curve, because all of them hit the mark. But so a couple of the first few homework questions, you're going to need to use the calculator. Alright, if you have any questions, let me know.